A sixth-generation fighter is a conceptualized class of jet fighter aircraft design more advanced than the fifth-generation jet fighters that are currently in service and development. Several countries have announced the development of a sixth-generation aircraft program, including the United States, Japan, Russia, the United Kingdom, France and China. 1. The first sixth-generation fighters are expected to enter service in the 2030s. While still at an early stage of development, several distinct characteristics common to many sixth-generation fighter concepts have evolved. The fifth-generation abilities for air-to-air capability, battlefield survivability in the anticipated anti-access, area denial environment and ground support attack will need to be enhanced and adapted to the future threat environment. An initial focus on air superiority roles has moved away from close-in dogfighting, which is becoming less common, and instead broadened to embrace ground support, cyber warfare and even space warfare capabilities, with beyond visual range, BVR, air-to-air missile capability remaining important. The flexibility to undertake manned and unmanned missions is also sought, along with the ability to integrate with more numerous fleets of satellite drones and ground sensors in a high-traffic networked environment to deliver full data-to-decision (D2D) capability. Advanced digital capabilities including high-capacity networking, AI, data fusion, cyber warfare, D2D and battlefield command, control and communications, C3 capabilities. Optionally manned, with the same airframe capable of conducting piloted, remote-controlled or onboard AI-controlled missions. Enhanced human systems integration, with virtual cockpits presented via helmet-mounted displays which allow the pilot 360-degree vision with AI-enhanced battlefield awareness, and replacing conventional instrument panels. Advanced stealth airframes and avionics. Advanced variable cycle engines able to cruise economically but still deliver high thrust when required. Increased range standoff and BVR weapons. Potential use of directed energy weapons such as a laser CIWS. The feasibility of some of these characteristics remains uncertain. Development time and cost are likely to prove major factors in laying out practical roadmaps. Specific requirements are anticipated by some observers to crystallize around 2025. In July 2014, Jane's Information Group reported that a House of Commons Defence Select Committee had published a report about the UK's post-2030 combat aviation force structure. The report highlighted a possibility of the UK committing to a next-generation fighter program to potentially replace the Eurofighter Typhoon post-2030. The Eurofighter Typhoon has since had its intended service life extended to around 2040. In July 2018, then British Secretary of State for Defence Gavin Williamson unveiled the UK's combat air strategy and announced the development of a sixth-generation fighter concept named the Tempest for the Royal Air Force at Farnborough Airshow 2018. France, Germany and Spain are also jointly working on a sixth-generation system. A test flight of a demonstrator is expected around 2027 and entry into service around 2040. On the 26th of August 2013, Russia revealed it would proceed with development of a sixth-generation jet fighter. They say the aircraft will most likely be pilotless. However, they would not skip completing development of fifth-generation fighter projects, like the Sukhoi Su-57. Mikoyan POK-DP is a Russian program to develop a next-generation interceptor aircraft to replace Mikoyan MiG-31. According to the Russian defense analyst Vasily Kashin, the aircraft would be considered as a 5++ or sixth-generation fighter project. In January 2021, Rostec Corporation, the owner of Mikoyan, announced that the POK-DP had now entered the development phase, saying, "Development of the next generation of interceptor fighters has already begun."
In an interview on the 8th of October 2020 to celebrate the 88th anniversary of the Indian Air Force IAF, Air Chief Marshal Rakesh Bhadauria was asked about plans for sixth-generation technologies and he responded that they have a clear roadmap for sixth-generation combat systems like directed energy weapons, smart wingman concept, optionally manned combat platforms, swarm drones, hypersonic weapons, and other equipment. India has been working to develop its fifth-generation AMCA with development completing in 2028 and production commencing in 2029. It is also looking to add some sixth-generation technologies in later variants such as an optionally manned, directed energy weapons possibility as anti-missile system capable of controlling UCAVs and swarm drones, but Indian officials did not claim that this will be a sixth-generation fighter.
Air Chief Marshal Vivek Ram Chaudhary on the 22nd of October 2021 confirmed in an interview that IAF is committed towards development of AMCA aiming at sixth-generation niche technologies.
After successfully developing its fifth-generation fighter J-20, China is now working on the development of a next-generation aircraft. Dr. Wang Haifeng, chief designer of the Chengdu Aerospace Corporation, announced that China had begun pre-research on sixth-generation aircraft in January 2019, predicting that the program would come to fruition by 2035.
The United States Air Force, USAF, and United States Navy, USN, are anticipated to field their first sixth-generation fighters in the 2030 timeframe. The USAF is pursuing development and acquisition of a sixth-generation fighter through the Next Generation Air Dominance (NGAD) program to replace its existing air superiority fighters such as the McDonnell Douglas F-15 platforms and the Lockheed Martin F-22 Raptor. The USN is pursuing a similar program using the same name with the fighter component called the F-AXX, likewise intended to complement the smaller Lockheed Martin F-35C and replace its existing aircraft such as the Boeing F-A-18E, F Super Hornet. The U.S. Navy launched its sixth-generation F-AXX program in 2008 and the USAF sought initial responses for a next-generation tactical aircraft, Next-Gen TACAIR, which would become the FX program, in 2010. In April 2013, DARPA initiated a study to try to bring together existing USAF and USN concepts. Next-generation fighter efforts would initially be led by DARPA under the Air Dominance Initiative to develop prototype X planes. The U.S. Navy and Air Force would each have variants focused on their mission requirements. However, also in 2013, the RAND Corporation recommended that the U.S. military services avoid joint programs for the development of the design of a sixth-generation fighter. They found that in previous joint programs, different service-specific requirements for complex programs had led to design compromises which raised costs far more than normal single-service programs. In 2014, a broader approach to offensive technologies was proposed, with USAF aircraft anticipated to operate alongside ground-based and non-kinetic anti-aircraft solutions, and with a greater weapon load than current fighters. In 2016, the USAF consolidated this change of course for its Air Superiority 2030 plan, to pursue a network of integrated systems disaggregated across multiple platforms. Rather than focusing on the sixth-generation fighter, the Air Force and Navy requirements had already been merged the year before and were now formally integrated, with the joint focus to be on AI systems and a common airframe. Boeing, Lockheed Martin and Northrop Grumman have all announced sixth-generation aircraft development projects. On September 14, 2020, the USAF announced that a prototype aircraft component of the Next Generation Air Dominance (NGAD) program had flown for the first time. The details remain classified. Concepts and technologies. There are significant differences between Navy and Air Force visions for their respective next-generation jet concepts, but both agree on some fundamental characteristics. These include artificial intelligence as a decision aid to the pilot, similar in concept to current sensor fusion. They will also have positioning, navigation, and timing, PNT, and communications that allow big data movement between both services aircraft. The USAF regards stealth as extremely important for the FX, while the US Navy emphasized the FAXX should not be so focused on survivability as to sacrifice speed and payload. Unlike the previous F-22 and F-35 development programs that depended on new technologies that drove up cost and delayed introduction, the Air Force is intending to follow a methodical path of risk reduction to include as much prototyping, technology demonstration, and systems engineering work as possible before creation of an aircraft actually starts. Sixth-generation strike capability is envisioned as a move beyond the limitations inherent to the potential abilities of a single strike aircraft.
Sixth-gen combat awareness will require a theater-wide integration of diverse systems beginning with the primary airborne sensory suite and further including real-time data linking of ground-based detection and ranging technology with sensors aboard primary and support aircraft. Advanced communication capabilities, unparalleled capacity for continuous onboard info stream processing utilizing AI for real-time data translation and rendering geared toward optimizing pilot situational awareness while reducing workload. Potential near-space capabilities, extension of existing strike standoff ranges, seamless cooperation with ground-to-air defense assets and the ability to deploy aircraft in manned, optionally manned, unmanned and stand-in options. In March 2015, the Navy revealed they were working with the Air Force to potentially release Joint Analysis of Alternatives (AOA) in 2016 for their next-generation fighters. They are allowed to take a joint AOA, then define a service solution that would be good for each service.
The Navy is focusing on replacing the capabilities of the fighter with a wide range of options for the Super Hornet, as well as the EA-18G Growler.
The AOA will run parallel to several other design and technology efforts including engine technology, airframe molds, broadband and IR stealth, and new ways to dominate the electromagnetic spectrum.
Part of the Navy's calculus will be based on how the F-35C performs as a critical forward sensor node for the carrier air wing. How the fifth-generation F-35C integrates with the rest of the air wing to give greater capabilities than what the platform itself can do may lend itself to the sixth-generation F.A.